I would now like to find the center of gravity of this pencil. All right. To do this, I can apply a normal force at the bottom of the pencil. And when it balances, I then know that the resultant center of gravity of the pencil must be directly over my finger. Okay, let's solve this analytically. So I'll switch to the desktop view here, and we have this pencil, and let's just assume that there are 3 different components making up this pencil. I understand that it could be more, but let's just break it down into 3 components for right now. Okay, so I have this pencil, and I've broken it down into 3 components, kind of the cap, the main body, and the eraser part of the pencil. And each one of these single parts has its own center of gravity, all right? And I've labeled those, the weight of this single component, W1, and it acts upon this location here. So now we want to find the entire center of gravity of the whole pencil. And to be able to do that, I like to make a chart like this, all right? So we have different columns. We have the weight here. And for segment number 1 here, we know the weight is W1. Likewise, W2 for segment 2. And W3 for segment 3, okay? Now for this X tilde is the distance away in the X direction that the center of gravity for each component acts. For example, for component number 1 here, the center of gravity acts 0.25 away in the X direction from our origin. And we can choose the origin to be anywhere we want. So I'm going to write 0.25 here. And then W2, it acts a distance of 0.25 plus 2, so that is 2.25 here, okay? And lastly, W3 is 0.25 plus 2 plus 2.25, that is 4.5. All right, lastly, we take the multiplication of these 2 columns together. So the first one turns out to be 0.25 W1. The second one is 2.25 W2. And the last one is 4.5 W3. And in many problems, we will be given the actual weight in newtons or pounds here for each of the components. Now we need to get to our formulas, all right? To find the center of gravity, which often, if it's the X direction, we put a bar on top. Many times in mathematical calculations, a bar on the top means an average, okay? And it's kind of like we're doing an average here. We're trying to find the center of gravity, which is kind of the average location of the weight, all right? And this is equal to the sum of all the components, X tilde times W, divided by the total sum of the weight. Okay, so don't let these symbols confuse you here. It just means add everything together. So we take the sum of all X tilde times W here. So that means we would add up this entire column. And looks like that comes out to be 0.25 W1 plus 2.25 W2 plus 4.5 W3. And then we also need to add up the sum of all the weights here. And the sum of the weights equal W1 plus W2 plus W3. Okay, so to find the centroid now, we use this formula. We have X bar is equal to the sum of X tilde times W, 0.25 W1 plus 2.25 W2 plus 4.5 W3 divided by our total weight, which is W1 plus W2 plus W3. Now, with that being said, we have, if we had numbers for each W1, W2, and W3, we could figure out this value. Likewise, if we want to do the y direction, all right, this formula looks very similar. It is just y tilde times W over the sum of W, all right? And in the z direction, if we have a three-dimensional problem, it's very similar. So we have z tilde times W divided by the sum of all the weights. All right, so yeah, we know that x bar here, we would take all the x tildes all the way down, but we could do that also for y and z as well. Okay, now this is for composite, kind of adding composite components up. So we're adding the components up. If we want to talk about the differential equation, instead of having a sum here, we're going to integrate this y dw. I'm sorry, x dw. X dw. Okay? And this x tilde dw and over the integral of dw. So if we just have an arbitrary kind of differential element and we're trying to sum it up over the whole shape here, right? We need to know this distance that it's acting away, x tilde, and then we multiply it by the small differential element dw here. All right. We won't use this as much, but if you're given a mathematical equation, you need to use this equation, and likewise, we have the equations for the y direction and the z direction as well. So that's a brief introduction to how to solve problems for the center of gravity.